We use coordinates in 3 dimensions by introducing a z-axis. So imagine we have a cuboid. So we have 3 dimensions in the cuboid. We've got a x direction, a y direction, and we can go forwards and backwards as well. That's a z direction. So x, y, and z. When we want to find the distance between 2 points, we use Pythagoras. So it's the same as if we are using it in 2 dimensions. We just use Pythagoras in 3 dimensions, the same way that you would to find the diagonal on this cuboid. So all we're going to do is we're going to do the square root. So it's the distance from the origin. So it's 2 along the x, 5 back down the y, and 4 in the z direction. So it's 2 squared plus 5 squared plus 4 squared. We could have written a negative 5 squared here, but either way, negative 5 squared and 5 squared are both equal to 25. So we can just type it into the calculator. The square root of 2 squared plus 5 squared plus 4 squared, and we get 3 root 5. So 3 root 5 units. Okay, one for you to try. Pause the video, give it a go. So we're using Pythagoras in 3 dimensions. It's the square root of 5 squared plus 5 squared plus 5 squared. So square root 75 simplifies to 5 square root 3. Find the distance between point A, with coordinates 2, negative 5, 4, and B, which is at 7, 1, negative 1. So we're just looking for the change. What's the change in the x? What's the change in the y? And what's the change in the z? So the change in the x between 2 and 7 is 5. The change between negative 5 and 1, that's 6. And the change between negative 1 and 4, that's 5. So we look at the difference between the coordinates, then square them, add them up, and square root. So again, it's a 3D Pythagoras question. So the square root of 5 squared plus 6 squared plus another 5 squared is square root 86. One for you to try, see if you can give it a go. So we're looking for the distance between 2 points. So how far in the x direction? It's a distance of 3. The sign doesn't matter because we're squaring it. In the y direction, we've got a distance of 4. And in the z direction, we've got a distance of 10. So we've got 3 squared, the square root of 3 squared plus 4 squared plus 10 squared. And we have 5 square root 5. The coordinates of A and B are 2, 3, 4 and 1, K, 6 respectively, given the distance from A to B is 3 units. Find the possible values of K. So we're going to set up our Pythagoras question. So the square root, the difference between the x's is 1. The difference between the y's, we can either write as k minus 3 or 3 minus k. Either way round, I'll put k minus 3. And the difference between 6 and 4 is 2. And that's going to be equal to 3, because we know the answer the distance is 3. So let's square both sides. So we've got, on the right, 1 squared is 1, plus k minus 3 squared, plus 4 equals 3 squared, which is 9. So I've squared both sides, so I've squared the whole of this and the whole of this, and I've just simplified the 1 squared and the 2 squared as I've gone. So we get k minus 3 squared. If we take away 5 from both sides, the 4 and the 1 make a 5. Take away 5 from both sides, we get 4. So k minus 3 is plus or minus the square root of 4, which is 2. So k can be 3 plus 2, which is 5. Or k can be 3 minus 2, which is 1. One for you to try. See if you can give it a go. So let's set up our equation. So the distance between the x's is 3. So the square root of 3 squared. The distance between the y's is 2, plus 2 squared, plus k minus 3 squared, square rooted, equals square root 29. Square both sides. So we've got 3 squared plus 2 squared, plus k minus 3 squared, equals 29. 3 squared is 9, 2 squared is 4. So we've got 13 plus k minus 3 squared equals 29. So take away 13 from both sides. K minus 3 squared is 16. So k minus 3 is plus or minus the square root of 16, which is 4. So k can be 3 plus 4, which is 7. Or k can be 3 minus 4, which is negative 1.